Good morning. Obviously, there are problems with traffic today in Athens, so we are late. Just to ask Antonia, shall we start or shall we wait some other audience? Okay, thank you very much. So, good morning, everybody. I'm happy that you could arrive to this meeting. Just for beginning, a nice color of the European problems with earthquakes. You see that here on south we are quite in hot red area. North it's much colder, and that's why in civilizations in the lower part of Europe developed on very dangerous places. And so that's why we are also having today a little bit to talk about, to have a little discussion. But as a first, I have to thank Professor Antonia Moropoulou to bring us together, to give us opportunity to express our thoughts about the problems with earthquake in this panel. And it was very, very interesting all these days, and I expect today as well. Please, next slide. Yeah, I will. Okay, thank you. Sorry. So here is very eminent group of panelists today. I'm going to moderate together with Professor Spirakos, not here, but I will do my best. Professor Stavroulakis Georgios is a reporter. Thank you. And here we have 3 presentations which will be on web. Antonio Formisano, Dritsa Stefanos, and Papa Nicolaou Corina. And most of us, we are almost here. So I would invite Emeritus Professor Penelis Georgios to give his presentation. Please do.
Good morning, everybody. I will try to summarize some milestones for the structural restoration in seismic regions. The basic principles in restoration are the following 2. First, authenticity must be considered the most important parameter, and second, life safety of the users must be considered equally important. However, authenticity and safety are two components contradicting each other. Authenticity asks for preservation without intervention at all, if possible, while safety usually asks for interventions for strengthening of the structural system, which might falsify the genuinity of the culturally protected building. These interventions become crucial in case of monuments in seismic regions. In this respect, the archaeologists, the architect restorer, and the structural engineer involved in the restoration of a culturally protected building are asked to find a common topos of coexistence so that the outcome of the restoration could satisfy both authenticity and safety. Here in this picture we present the 3 main areas with their requirements: historical, archaeological, restorer, architect, and structural engineer. Each of them, they think that in the beginning that his requirements are the most important. Then they have to approach each other until a common place may be found, so that the common area in the second 3 circles, so that the restoration may be applied. In order to minimize the extent of the structural interventions, the following parameters must be taken into account seriously: the form of the structural system, its history, and its modifications, the materials, the construction techniques used in each phase of the building, and their mechanical, chemical, and physical properties, the existing damages and deformations, cracks, spalts, drifts, settlements, and their time history, and finally the load, and particularly the seismic actions, as there is not any guarantee for their ceiling, for the ceiling of their value. I had a long discussion in Istanbul for the Hagia Irini, for which earthquake should be analyzed for the next of its life. It has survived 1200 years, and for how many years, and with which earthquake should be analyzed. There is not a ceiling. Diagnosis and analysis are the basic pylons for the structural assessment. The structural assessment of the bearing capacity, particularly for seismic actions, cannot rely only on analytical procedures, despite of the storming development of the computer science in the recent years. The low reliability of material properties, existing cracks, drifts, and uncertainties in seismic actions, to which I referred just before, influence seriously the guide for the structural assessment. The basic guide for the structural assessment should be the evaluation of the in situ and laboratory findings, form, materials. All these are called diagnosis, and diagnosis makes possible the qualitative connection of the causes and effects based mainly on facts, which are the cracks, the material quality, the inclinations, and so on. And in this respect, it constitutes a deductive procedure of higher reliability than that of the analysis. The qualitative information of diagnosis must be the basic criterion for the level of reliability of the quantitative results of the analysis. In this flowchart, we have diagnosis on one side, quantitative safety evaluation, that is analysis, on the other. If they compile, if the conclusions of these two activities are compatible, we proceed to the choice of intervention scheme. Otherwise, we have to rehabilitate, to reconsider mainly the quantitative analysis. Based on the structural assessment, the structural restoration scheme is decided. For the suitable choice of the techniques and materials, irreversible and reversible techniques, together with compatibility and durability for intervention materials, should apply. For the formation of the structural restoration scheme, there is a need of a close cooperation, mainly between archaeologists, architects, and structural engineers, as I mentioned from the beginning. Closing, I would like to say that having a vast experience in research and structural restoration of prominent monuments, but also in modern buildings in the last 50 years, I am sure that the collaboration between the above professionals may be more effective and fruitful if each of has some understanding of the other's aims, needs, and approaches. Below, I will show you 2 or 3 pictures of monumental buildings I was involved in, and also a modern one nearby. Rotonda of Thessaloniki, it was restored 40 years ago after the big earthquake of Thessaloniki. Theological School of Halki in Istanbul, it is now under restoration. The Church of Xenophon Monastery, it was restored. The restoration had finished 1 year ago, and then there was a rather big earthquake in Ionoros, in Mountain Athos. And anew, the Stavros Niarchos Cultural Center nearby, which was put in use in 2016. Thank you.
Professor Panelli, thank you very much. Maybe one comment, I very much agree that interventions should be limited as much as possible. Yeah. But we also have to give the message that the proper maintenance during the lifetime of monument should be performed.
Yes.
Thank you. I would like now to invite Professor Formisano Antonio to give, I see here already we have, to give his presentation.
Good morning, everyone.
Sorry, it's wrong. Antonella, I'm sorry very much. Yeah, sorry, I'm sorry.
Oh, okay. So please.
It's online.
Oh.
It's mine or Longobardi?
I don't know.
This is me.
Yeah, but here I would like to have this, Antonella. Yes, but is that going on?
Okay.
You have okay.
Okay. Thank you, Professor Zarmi. And I would like to thank Professor Maroupoulou. Would like to thank Professor Maroupoulou for this for the invitation to join this panel. That is very important for me because we are all in with the same problem in a very seismic place. And when we discuss about heritage, we all often think about monuments, but I think for the monuments, the process is more robust. And we have also to think about the diffuse heritage that are important component also our memory, our heritage, but they are not often protected in a strong way. So, and then when they are mostly Masonry, and when we think about Masonry, we think always the structural behavior of a box, and then we think that the behavior and the models which interpreted the seismic behavior of this element would be simple. With stiff elements that are loaded mainly in their plane. However, when we instead see the pictures and the damages of the past earthquakes, we observe unexpected behaviors that are not coming from the box-like behavior. So, and then the question is, what is not working? It seems that there should be sort of gaps between the effective behavior, the real behavior, and the structure models that we apply for the interpretation. So the assumption seems very far from the several common situations with regular flow levels, with line of buildings, irregular openings, irregular intervention, a lot of measuring discontinuities that are always affecting our historical center. And then we assume that the problem is not still very clear from technical and conceptual point of view, including cultural point of view. And it is a problem that is still not clear from also the code point of view. And sometimes it's difficult also to identify or define which are the structural elements because of the complexity of the geometry, the unknown connection between each heritage building, the measuring properties in the case, and the characteristics of the structural elements, and again, the change of the structure in time, because the seven intervention made a very complex structural element with weakening caused by the lack of connection, with sharp discontinuities connected to the historical phases with infill openings and so on. All damages lack of connection, which can of course weaken all the structural organization, and during the earthquake this can trigger to overturns during the earthquakes. But again, we have to consider how, for example, common elements like the chimney flows could affect the behavior. And again, the measuring quality that can vary and be more complicated of what we could understand. And other point are the several past intervention. In fact, at least in the last earthquakes in Italy, we found that the damages were not, of course, considered by the models, structural models, but also the retrofitting techniques that were common till the from 2000, I mean, and led to create a sort of hybrid behavior between masonry structure and the new addition that they were usually in reinforcing concrete, but this means that the compatibility between these materials were not considered, and all the process, including the compatibility, all the process related to the control of the intervention was not considered in a proper way. I mean, till a certain point, we believe that reinforcing concrete could solve all the problems of the masonry building. So in some cases, the lack of compatibility with masonry or the poor application led to, of course, this brittle behavior, particularly lack knowledge of the masonry characteristics, particularly stone masonry, that of course is the most brittle, but also some of these applications, so the concretized roof and floor substitution led to unexpected at the time behavior. But if you think about the detail what could happen, so we can understand that is lack of compatibility with massive intervention and masonry structures. And the intervention, the damages were very clear, particularly about also when we substitute a floor or a roof with reinforcing mix tire reinforcing concrete structures. And the damages here are very clear, but also some strengthening technique applied to the masonry itself, like, for example, jacket walls in some cases were not effective due to the lack of connection, discontinuities between the application, but also simply the durability of these metal nets that, of course, in presence of moisture and the base of most of the historical heritage building is wet due to rising damp, led to the corrosion of the protecting elements. So in any case, also the application of grouting, that we believe that grouting was effective, but in most cases the masonry is not injectable at all because they have a poor quantity of void. So the idea to reinforce this building, for example, with the diffuse spot that you can recognize in this picture, was not clearly enough for the effectiveness of the structure behavior of the structure. Then we have the review of the codes, and since 2003 we have some new requirements. So we have to take in account that the building should be known, starting from a simple step that was a geometrical survey, but also within this geometrical survey recognizing which are the elements that were transformed, and then historical research is part, and a very important part, of the structure assessment and of the past intervention. Again, material and decay and damage survey, so the present state of the building with its material and its state of conservation, the mechanical characteristics of the materials that we have to evaluate for the intervention, including ground foundation. And the knowledge must be continuing time, considering monitoring within a process, as Professor Zani said, of continuing control and maintenance of the building. But even if the knowledge connect the code connect the knowledge of the building with the safety through some codes. It's very curious that also now probably the memory of the most important in earthquakes decrease, and in many cases the knowledge approach is less robust because a lot of part of the professional community consider it as a waste of resource. And I remember yesterday that Professor Papayani in the panel 9 that said, yes, we are studying mortars, and we found in laboratory that the behavior is more effective, but people knows about cement mortars and they continue to use them. And also if the code said that you must know before the building, and if you know the building very well, you will select a more effective intervention. So people prefer to have a lower knowledge and to carry out a more massive intervention, because probably they have not trust also in some idea, even if it was diffuse. So then we have to take in account another thing. Yes, one important thing that Professor Paiani always said about AI. So, what is the database? For the Masori, the database changed a lot if considering before the 2000, after the 2000, and the present, because now we have in many cases new technique, FRP or other the new materials coming from from other fields, like in this case. We are doing a lot of tests about structure behavior, but which is the real effective application? And again, which is the durability of these new materials? So we have not to do the same mistake in the systematic application of reinforcing concrete. We have also to collect information about are they effective? Is there any database of the behavior of such element in new intervention, and how is the intervention after 20 years, 30 years, and for the earthquakes. Also, the durability seems very low. We can conclude that diagnosis knowledge is the base of the seismic assessment and vulnerability mitigation. Thank you. Sorry.
Thank you very much for this very brief overview of our problems. And I would like to ask other reporters to be, within the limits of time, because we are a bit late. So now I am inviting Antonio Formisano. I made a mistake before, from University of Naples. I think it is online, if I remember well.
Good morning, everyone. I speak on behalf of Professor Formisano. I don't know if he informed the organizers. Okay, just a moment.
Please go on, it's okay.
Okay. Good morning again, everyone. I am Giovanna Nobopardi, an engineer that worked with Professor Formisano, that unfortunately was not able to participate to this panel discussion. But we would like to thank all the organizers for this kind and interesting opportunity. We prepared this small presentation, mainly focused on Italian cultural heritage. As well known, Italy is one of the European countries with the highest number of cultural sites spread all over the peninsula. And this cultural heritage includes not only archaeological monuments, let's think about Pompeii, but also historic villas and palaces and ecclesiastical buildings, churches, cathedrals, bell towers. Most of these constructions are nowadays in advanced state of decay due to the natural aging of materials, but also for a lack of maintenance over the past centuries and decades. And for these reasons, such constructions could be affected by different types of mechanisms, both of local and global type. For example, concerning local mechanisms, they involved single portion of a structure called macro elements, and they are associated to overturning and bending phenomena. If these first mode mechanisms are neglected, there is the global response of the entire structure with the shear phenomena across the perimeter masonry walls. But we can consider in some way, as part of cultural heritage, also clustered buildings, since they shape, they characterize the landscape of historic city centers, not only in Italy, but generally all over Europe. What are clustered buildings? They consist of several structural units erected in continuity one to each other, and they also represent The results of an unplanned urban development occurred in the past centuries without any regulations. And as depicted in this picture in the bottom part of the slide, their construction process could last several years. The process originated with the two single buildings identified with the letter A. Then we have the construction of a building such as the building B in continuity. And then in order to fill the space, the empty space between two individual original buildings, there is the construction of the so-called saturation units. In this way, we obtained an aggregate, a mesory aggregate. However, cultural heritage clustered buildings in most of cases are placed in area having high seismic hazard, as evidenced in this picture. So there is an urgent need for a consolidation plan in order to improve their seismic behavior. How to define a proper and an adequate consolidation plan? Obviously, it is necessary to conduct an evaluation of the seismic vulnerability. For example, we can use the provision given by Italian guidelines for cultural heritage, which propose 3 distinct evaluation levels analysis, starting from the territorial scale up to the individual building scale, in order to investigate and to understand the behavior of the structure and of its single part. Based on the results, we can select some seismic retrofitting solutions, ranging from traditional methods, which include scucci and cuci, consolidating injections, and innovative solutions. Particularly, that innovative solutions try to combine the improvement of the seismic performance with energy efficiency. And for example, we can recognize the plaster reinforced with natural fibers. So in some cases, there's innovative solutions used sustainable materials, natural materials, in order to reduce the environmental impact. So in conclusion, this topic is very important, but it is also very challenging because it's not easy to acquire structural geometrical information about cultural heritage, but it is very essential to understand their behavior and to consolidate such constructions in order to avoid the loss of this huge patrimony and obviously the loss of human life. Thank you.
Thank you very much for very efficient and short but clear presentation.
Thank you.
So we are now calling Professor Ioannis Psycharis to give his presentation.
Okay, thank you. It's a great pleasure for me to be in this panel, and I would like to thank Professor Moropoulou for giving me this opportunity. I would like to talk about the earthquake response of classical monuments. And as you all know, the columns of classical monuments are made of drums, which are placed one on top of the other without mortar. So during earthquakes, the horizontal forces are transmitted mainly through friction, and the drums are allowed to rock and slide. This makes them kind of spinal constructions, and for this reason the seismic response is highly nonlinear, very sensitive even to very small changes of the parameters, and very complicated. And of course special analysis methods and software are needed to calculate it. Just to get an idea of how this structure responds to earthquake, this is an experiment on the shaking table. These are columns of the Parthenon in a scale of 1 to 3. Apparently the 3 columns are the same, but there are very small difference between them, construction difference, which as you see produce very different response, and this is the sensitivity I was talking about. And this is another experiment showing you how these columns in the corner formation respond to the earthquake. You see that during the earthquake they can be close to collapse, but after the earthquake they might be stable again. So the question is, can such structures survive strong earthquakes? And the answer is, despite that their apparent instability, classical monuments are in general earthquake resistant in their intact condition, meaning when there is no damage. This can be proven analytically, and here I show you a graph showing the possibility of collapse of a single column of the Parthenon. This analysis were made for 3,500 artificial near-fault ground motions, and you see that the possibility of collapse is very, very small, except of a very strong earthquakes of magnitude larger than 7 and very close to the structure, less than 10 kilometers. But even in that cases, the possibility of collapse is less than 40%. The stability, of course, is also proven from the fact that many classical monuments built in seismic-prone areas have survived for almost 2,500 years. However, we must have in mind that many ancient temples have collapsed. So what are the factors that affect the risk of collapse of these monuments? First of all is the slenderness of the columns. The more slender the column, the more vulnerable it is to earthquakes. The second parameter is the absolute size of the structure. This means that smaller structures are more vulnerable to earthquakes than larger structures with the same aspect ratios of dimensions. Similar structures, but larger, are more stable. The third one is the predominant period of the ground motion, with long period excitations being much more dangerous than high frequency ones. Of course, the connections between the structural members play an important role in the structural response, and finally, the damage is very, very important. So, because today these structures have damage, interventions are deemed necessary to reduce the risk of collapse to an acceptable level. Typical restoration actions include addition of missing fragments of the drums, restoration of inclined columns to the vertical position, addition of missing and replacement of existing connections with new ones, usually made of titanium, and fixing foundation problems. Such actions bring the structure close to its initial intact condition, but again, the today surviving structure is only a part of the initial building. So even after interventions, there might be danger of collapse during a strong earthquake. Unfortunately, enhancement of the stability of these structures is very difficult or even impossible because the aesthetics and the original architecture have to be preserved. This is what Professor Penellis mentioned before. And for this reason, each monument is a special case that has to be looked individually, and interventions to be applied have to be chosen carefully and after appropriate analysis. One way to enhance the seismic stability that we propose is this so-called tendon system. This is a tendon which we propose to be placed inside the columns, passes through the columns. They are unbonded tendons without any bond, and the tendon is anchored at the foundation at the top of the column. During the seismic response, due to the rocking, there is an elongation of the tendon, and this produces a restoring force, a compressive restoring force, which tends to bring the column back to its initial position. The restoring force increases as the deformation increases, so we end up with a controlled rocking system, we would say. The advantages of this system is that the tendon is not visible, so we do not affect the aesthetics and the architecture, and the intervention is reversible in a way, except of the small hole that has to be drilled at the center of the column. We proposed to apply this system at the restoration of Pythias of Poland on the Acropolis of Rhodes. In that case, the columns will be restored with totally new material, so to drill the hole for the tendon is not a problem in this case. And the results show that the proposed system with proper selection of the tendons enhances the seismic stability, preventing collapse in the anticipated seismic motions that we examined. And just to show this, this is the response of a single column of this monument to 30 seismic motions. The open circles are without the tendon, the solid circles are with the tendon, and you see that without the tendon, the column collapses in about 40% of the seismic motions. With the tendon, does not collapse to any one of them. So this seems to be a promising solution. Thank you very much.
Thank you for a very interesting, innovative approach. And now I would like to call Professor Mouzakis Paris to give his presentation.
Thank you, Mr. Chairman. Ladies and gentlemen, I'm going to present you some tests we perform at the Laboratory for Earthquake Engineering with a masonry structure, two-storied masonry structure, reinforced. And this is a cooperation between the University of Shinshu in Japan and our university. The structure has 2 floors. We perform triaxial tests. It's 1:2 scaled the specimen, and it was constructed with a double Flemish bond of 2 bricks thickness. The first story has a timbrel vault, and on the second story, timber joists and planks exist. That's how this masonry was constructed. We used bricks of 30 by 50 by 100 millimeters. The joint thickness is 5 millimeter. The compressive strength of the brick was 14 megapascal, and the mortar had a strength of 6.3 megapascal at the time we performed the shaking table tests. We started with some initial tests to find the compressive strength of the initial material, and then of the confined material. I'll explain later about this confinement. Then we perform tests for 4 bending tests perpendicular to the bend joints according to EN 1052-2, and you can see the crack failure during this test. And then we perform a similar test with 4-point bending parallel to the bed joints. The timbrel vault is a structure that typically encountered in Spain, especially in Catalonia, and is made of tiles. You can see here how the vault intersects the walls of the structure, and that's a photo of the top from the top and from the bottom. Then we performed triaxial. We placed the triaxial accelerometers. We used wire displacement transducers and a system with stereoscopic videometry using targets on the specimen. which has an accuracy of 0.1 millimeter. Here is the test of the original structure. The peak acceleration is 48% of G. Many cracks appeared, but all these cracks mainly can be attributed due to bending and not to the shear sliding of the bed joints. Then we decided to strengthen this by using steel beams, and we did 3 different arrangements. In the first one, we strengthened for bending all the piers, and then we calculated the we find the shear strength, taking into consideration the capacity design of the moments, and then we strengthen also for shear the structure. For the second series of tests, we took out all the strengthens the beams, horizontal and vertical beams that were used to strengthen in plane for shear, and at the end we took out also the 4 angle beams that were used at the 4 corners of the building. The maximum acceleration the structure suffered without any damage was now 1.5 G, about 3 times higher than the unreinforced structure. In the second case, exactly the same acceleration, and for the third case, we reached the same acceleration without any damage. You can see here the 1.5 G test. This looks like that it's a very stiff, and it's not needed to strengthen for shear. Then we repeated the test. And that's the last one, where no corner beams exist on the specimen, none of the beams. Oh.
Thank you very much for very interesting and very instructive presentation. Well, it reminds me on the classic strengthening with the wooden planks. Yes. So it's obviously the old masters understood earthquakes as well. Thank you. Now I would like to invite Professor Dritsos Stefanos. He is with us on the web. Dritsos? So, floor is yours. You hear me?
Yes, I can hear you.
Okay.
Share screen.
Can you give us your presentation, please?
Sorry.
Can you give us a presentation?
Just a moment. Probably.
You have technical problems?
Can you see me? Can you see now my presentation?
Yes.
I have already shared. Can you see? Can you see my presentation?
Yes, we can see it.
You can see. Okay. Okay. I apologize for these problems. First of all, I would like to thank you very much, Rocco, for to be here in Athens. We are glad to see you. And of course, I want to thank the organizers and specifically Tonya for giving me the opportunity to participate in this panel and try to give a sense of CAVET, which is the code for the assessment and structural derivation of massive structures, which can be used as a very useful tool also for heritage structures. The objectives of CAVET, I just very quickly say that set the rules for the inspection, the surveys, the investigation, the documentation of the structure, and there are specific references to monumental and preserved structures. Also, they set a specific criteria for assessing the seismic response of the masonry structures and give the appropriate approach to select the appropriate measures for the interventions. Also, there are criteria for the redesign and the retrofitting of the structure. The field of application covers all the masonry structures that formed by masonry units and connected with mortar. However, it is evident that the underlying main principles of mechanics are for general use. Dry stone masonry structures are not included. Preserved buildings and monumental structures is included. It is a main part of the code, and also including structures that are made from tip and frame masonry and from composite beam body structures. The obligation of the code provisions depends on the expressions that are in the text. Somewhere you can find that it be must, apply, may, propose, and the comments that are in the code have the same force as in the main text. Also in the code, it is allowed a partial satisfaction of the requirement of the code. This is under certain conditions. And either with an explicit reference to the code, this is these exceptions, or by a relevant decision of the parking authority. Also, it is allowed to use other evaluation methods besides those of the code under certain conditions. And in the code, you can see that the main concept of the damage, the performance level or damage level or limit states that are included in all the assessment codes are included in the code, including all these different performance levels that concerns minimum damage or significant damage or excessive damage. Concerning the seismic actions, which is the design, earthquake, and assessment, the pro or after a retrofitting work, which is the return period that should be selected. Should it be the same as the new structure? The answer is not, no. But it is a decision of the owner or of the public authority. And in the question, which is the maximum seismic action that leads to the accepted damage profile of a building? This is the accepted damage profile that the owner or the public authority want. And in this, to answer these questions, so different seismic classes are provided, so any structure can be evaluated and assessed for a specific damage profile, and depending on the capacity of the structures we can categorize the structures in different seismic classes, and this is very important for the heritage builders. For the intervention in masonry, for all the traditional and conventional techniques are included and described how this should apply, and also with the design work. And also it is focusing in the intervention with steel elements and other modern materials, also the technology and the design procedure. Some photographs from the main concept of the code, that the masonry with steel ties and other modern materials in order to provide the box behavior of the building is focusing. And that's all, and thank you for your attention. Here is the site with the English version of Cadet, which just published before some months. Thank you for your attention.
Stefano, thank you very much for a very interesting presentation. This Cadet is something what should be used around, not only in Greece. And I hope your presentation will be available to be downloaded somewhere. So now I would like to invite another speaker by web, Professor Corina Papanicolaou. So please, Corina.
Hello, good morning from a rather gloomy and cloudy Patras. It is rather chilly as well. It's so nice to see all of you. Thank you, Professor Zarnitz, for your introduction, and special thanks for the honoring invitation by Professor Moropoulou and the organizers to this conference. I'm not sure whether I have to share my presentation because I sent it yesterday by email, but I can share it, no problem. I don't know if you can see it.
Yeah, we can see it. Please go on.
Okay. My initial decision has been proven correct, meaning that my background includes 2 decades long research regarding the use of innovative composite materials and systems, namely inorganic matrix composites, textile reinforced mortars in particular, in seismic strengthening of structurally deficient masonry, for the most part masonry structures. So when I was invited to this panel, I decided not to even try and make a summary of this knowledge, but because the task seemed impossible for the 5 minutes that I was allocated. So I made the decision just to simply provoke the discussion on a very, very limited list of issues which I think are in rise right now. So It is an undisputable fact that our building stock is aging and that it is in peril. What I want to highlight and provide as a food for thought is that what needs to be contemplated is the combined action between seismic actions and other causes of risk, such as weathering, differential settlement, and fire. So multi-hazard protection is needed. As an example, I provide the example of fire following earthquake. What is our level of understanding regarding to this? Not much is done. FFE, as it is called, it is at its infancy right now, and there is actually a virgin field of research that lies ahead. Also, earthquake following fire is another issue that has to be taken into consideration. Another issue is the fact that the existing, and dear Antonella's presentation already included that. You might mention, dear Antonella, saluti, long time no see. The existing already in place strengthening means have already aged, and Antonella showed a photograph of it. How do we assess them? How do we treat parent system versus strengthening system, differential aging? So it all rolls back to the long-lasting issue of compatibility. Now compatibility has also a time aspect along with it. And the last but not least, and there was also a mention from Antonella regarding Professor Papaioanou's presentation in another panel, how do we integrate the use of artificial intelligence in strengthening and rehabilitation of historic structures? In this context, we have to bear in mind that what AI does is, by machine learning, knowledge discovery from data, KDD, and data mining, DM, AI is trying to find patterns and fill in the blanks for data that is missing. From the other hand, the result of machine learning and all these very nice approaches is only as good as the input data and the knowledge of the person managing the data. So by going through the very limited literature on this and citing the work of Perhaver and Kamik, one can see that there is a need for building digitization in a strictly controlled format in terms of database. And this needs to be tackled with within national level and then communicated internationally if we want any meaningful results to come out from this exercise. From the other hand, it is my personal belief, and this is not on the technical side, this is more on the philosophical side, AI will never fill in the shoes, let's say, of us engineers in terms of inspiration and even apophenia. Apophenia is a Greek word meaning that one has the ability to perceive meaningful connections between seemingly unrelated things. So yes, it might be a very interesting tool we might want to look into, but at the end of the day, it's the engineer who possesses the higher function abilities to decide on the intervention of historic and monumental structures, at least. So this is from my part. I hope I was brief enough.
Thank you very much, especially for the last philosophical thoughts, because I think that we should not be strictly oriented only on technical part, but we have to understand the wider aspects. So now I would invite Professor Nikos Pneumatikos, who will have a speech together prepared with author who is here on our...
Yes, thank you. Hello, everybody. I actually replaced my colleague, Phyllis Triantafylos Kokinos. He has an unexpected obligation and couldn't be with us today. First of all, I'm very glad to be here among so prestigious and experts in the field of earthquake engineering and structural rehabilitation of heritage structure. I'm not make any presentation. I just want to share some thoughts together. And the problem of earthquake rehabilitation of heritage structure is a compromise problem. We should come compromise with the different contradiction aspects. So we have structural intervention of one side, and the other side we have architectural intervention. Or we have the value of safety lives from one side, or from the other side we have the historical, aesthetic, architecture values. Or even though this come out to seismic force and how much seismic force we can calculate versus to authenticity of the structures. So this is a decision, this is a compromise that we should do all together with different directions, scientists with different directions. If we manage to find the equilibrium point, that's okay. If we don't, it's better to leave the structure, to pray not an earthquake happen, and to leave the things for the next year, for maybe other group of people from different direction can communicate and to find this equilibrium point, and or maybe new, better technologies come up and they find a solution. But of course we try to find this balance point. Some important issues should be taken into consideration. In order to see a better, a clearer picture, we have to understand from the structures the load-bearing mechanism, the path load, very clear picture to have about this subject. Also, we have technology test for material, for in situ, in laboratories, in order to understand the mechanical properties and to help us to make a better model to be analyzed. Also, we should have clear picture about the pathology, what the reason of cracks, what kind of cracks it is, not only how repair the cracks and all these things, in order to make a better model with good support conditions or other clear or other specific things during the structure to be modeled. So, and having a clear picture of this is a part of structural part of you. We should make some like a AutoCAD which has layer overlapping the seismic risks, overlapping the values of the structures, the architectural values, the historical values, or the heritage values, and then to use some theoretical techniques like multi-criteria analysis or use AI tools in order to find this equilibrium point. And if we find this equilibrium point, then we start to continue to apply the techniques that we decide all together from the archaeologist, the historical, and all the aspects. And this is the good scenario. But closing, I don't want to spend more time. I think I listen in every conference in a lot of things, and we focus so much in how let's thought that we find this equilibrium point, and we do the job, and we do the good job. Then what? So I see a lot of very good church which have been restored and then is empty. And nobody goes there to pray and to connect the structure with the social life. Of course, someone can say, but it's not our job, it's not our fields to go beyond the restoration. It's just a point of other social scientists or social matters. But I think social scientists maybe fail to connect or to motivate people to go beyond. So it's our also which we help in order to motivate the society to live with that in such structures. Or we see archaeological temple and no people philosophize. So we should, closing, I say, let's rehabilitate, restore the structure, and let's help also rehabilitate and restore our souls and ourselves. Thank you very much.
Thank you very much. You are very much in line with the whole conference. And I think that one of the words, one of the issues is adaptive reuse, which can bring life back, also in economical terms. So I would like to invite Giovanna Longobardi on web to give her presentation. Giovanna?
I made my intervention before.
Please.
With Professor Formisano.
Okay.
I already made my intervention.
Is it no? It's
already presented.
Is it already presented? Oh yeah. Sorry, I'm sorry.
No problem.
So now I would like to invite the Stavroulakis Georgios, please, to present your. Yeah, just a moment.
Thank you very much. I have prepared some slides before the discussion, so allow me to show you some thoughts which have been done before this discussion, and then I have the privilege to close the discussion and summarize what has been told. Well, we are talking about modern tools, computational mechanics, artificial intelligence, machine learning, image recognition, etc. And I would like to add here the structural health monitoring and the digital twins, and for good reason. What we are doing at this time, and you are invited to attend the technical presentations, is to use data within the structural analysis. That means to integrate experimentally or numerical calculated data within the structure. And this data can be updated during the life of the structure if they are available. This is an example of what we can do if we know the composition of a building, the composition of the wall. We can do numerical homogenization in order to put all ingredients in the mechanical behavior. At another level, we can take measurements of the whole structure and update the model during the life of the structure and take into account in a holistic way altering and all changes during the life of a structure, including, of course, damages due to an earthquake. We have done on the computer experiments comparing results with the predictions of artificial intelligence, and we have shown that this path works. This is an example of integrating the microstructure by means of artificial intelligence tools and make possible to use what was impossible several years before, multi-scale analysis within classical everyday structural analysis tasks, because the classical FEM square we all know it's very expensive tool. Well, the last thing is that we can introduce into artificial intelligence tools the classical mechanics, the classical rules of mechanics. And the modern trend is to create the so-called physics-informed neural networks. Instead of comparing measurements with the prediction of a network, you use the network itself, you differentiate the network, and then you try to fulfill the partial differential equations of elasticity, what we have done in the classical mechanics in the first years of our study. Well, other kind of tools, which will be presented in parallel sessions, are optical recognition of the shape, of cracks, of damages, whatever is required to fill first the WASP questionnaire and the questionnaire of FEMA, first step of evaluation after an earthquake of damages, and then to create a quick model in order to predict the results. Here is an example of what we can do. For example, if we have a picture of a masonry structure, we can evaluate from this picture directly the response or the collapse. Behind this is a database created by classical modeling, and then on top of it, it is an evaluation tool based on deep learning. Well, the reality, of course, is that we have in front of us old structures. We need a lot of information. We have to capture this information, as the other people have already mentioned. And we have now in Greece this canopy, Professor Grisos has given it in his talk, which gives a categorization of structures, performance levels, and seismic classes. Okay. If we think, in some sense, out of the box, on the other side we have sensors, but with limited life span. In comparison with the host structure, masonry structure, could be there for centuries. An electronic circuit will be useless after some years. So there is no guarantee on there, and the data, there's no guarantee how to preserve them for the next 10 years or so. If we resolve these problems and we have reliable sensors and reliable gathering and evaluation of data, according to my opinion, the optimal goal could be to have a reliable structural health monitoring system that warns us about the health of a structure and allow for further usage depending on the real condition of the structure. That means an updated structural digital twin, and not on the provisions of any canopy. Of course, this is not accepted for the time being from the law. This dilemma has to be discussed and resolved in the next years in the scientific community. Well, I stop here my presentation, so I have to...
Excuse me, one presentation is missing. I left mine to the end.
Okay.
So still, by intention I did it, so before your report.
I will continue then with the report after your talk.
Yeah, thank you very much. Please, can you give my presentation is in envelope there, in file? Yeah, for the first Jarnich and the second presentation. Yeah. No, up. Yeah, here on the second, yeah. Yes. Thank you very much. I will be short. I just left for the end. Well, I have a little provocation regarding the Eurocode 8 and the problems of cultural heritage. The problems which we meet every day I experienced some such problems when I was involved in some design of post-earthquake retrofitting in Croatia after earthquake. And let's see one fact. Earthquake engineering is old at least 25 centuries. Yeah, the first base isolated recorded buildings still now visiting 1,000 tourists is the Cyrus the Great Mausoleum, which has base isolation. On the level of stones, there is a level of sand and another level of stone, so it survived all the earthquakes. But I'm proud to say that in Slovenia, in Ljubljana, we have the first known modern base isolated building, so-called skyscraper. It is infill frame building from 1933. And this building we, in our country, have as a starting point of the earthquake engineering in Slovenia, which is now 90 years. Well, Eurocodes, we are all familiar with them. Many of us are working on it, we're working on it. This is a story 45 years already, since the start. But we have two cases of Eurocode for repair strengthening. It was the first version 8.14, which was replaced by Eurocode 3. The problem is that cultural heritage is even less addressed in the last one that was in the first one, which from my opinion, of engineering opinion, was practically more usable than the, but it's not critic, it's just my understanding. When we try to intervene in heritage, we have to somehow combine with conservation standards, national heritage laws and everything. So yesterday in panel 9, we had one very good statement in the last slide regarding this. I didn't know for that before. So, and also Stefanos showed us today some of possible solutions, what is developing here in Greece, what is very good point on. So we are using different tools. I'm using, let's say, Tremuri software, and the part of Eurocode can be fulfilled by assessment. But what is missing, it's not addressed. Preserving historical materials and architectural authenticity, working with conservation constraints, adapting intervention techniques to fragile and non-engineered materials. They're all open questions. And why? There is a problem. I'm a civil engineer, and I work with architects very well. I can also work and work with conservators. But sometimes conservators do not understand our problems because they're more concentrated to their problems. So when it comes to decision making and signing the project, it's always debate how far civil engineers, architects can intervene, what is in conflict with conservator rules. So some kind of, I don't know, regulations, especially in laws which comes in countries after earthquake, these problems should be somehow addressed to help both in conservators, architects, civil engineers to cooperate better. So we should discuss in future how far can the future development of Eurocodes address the specific issues of the interventions in cultural heritage. Do we need more precise requirements of the national post-earthquake retrofitting regulations regarding cultural heritage? Should precise requirements cover the retrofitting measures, including requirements on the appropriate material use and types of materials, including emerging ones, what we heard today? And can it contribute to better understanding and cooperation of investors, conservators, architects, structural engineers? And now the last slide to support Professor Moropoulou because Athena is waiting for her declaration. And we started to think about the heritage resilience since our project EU-CHIC, European Cultural Heritage Identity Card, in the same framework. It's now 15 years ago. And from that, we were thinking also of resilience. And that is some exercise here, which I did with my colleagues, how to understand the resilience of heritage. First, what we have to have is complete data as far as possible, because a value, or let's say value, of a monument, which was in the moment when it became in life, we cannot recover. We can try to understand, to get as much data as possible. But we have to know that at the end, when we are retrofitting, what I'm doing, we cannot bring back the whole value. But we have to work to do as much as possible. And that's why we need some declaration. Athena is waiting, and I hope this activity of Professor Moropoulou will be successful. Thank you. So, please, Rapporteur, floor is yours.
Okay, thank you.
We have it. I have some more to give you. Thank you.
Thank you very much. We had the privilege to hear a lot of interesting presentations and ideas from well-known colleagues in the topic of cultural heritage and earthquakes. First of all, Professor Penellis mentioned the milestone of structural restoration and the need of finding a common topos between archaeologists, architects, and structural engineers. And he mentioned also the question of finding a suitable design earthquake for a monument that already has a long history behind it. He mentioned also that the structural assessment can rely on computer science, but there is a need of making first a meaningful inspection and diagnosis, which is the first and most important step before using the modern tools of computer science. Professor Saissi then mentioned the question which investigation should be done for its intervention, and mentioned again the importance of evaluation of the current condition of every monument, and then she presented a critical review of relevant strengthening techniques and the problems each one of it may have. Then she mentioned the code requirements and listed all the requirements concerning knowledge of geometry, history, material, ground, and at the end monitoring. All of these topics introducing uncertainties which must be taken into account in order to safeguard the safety of the structure. At the end, she mentioned experimental database and the question how this could be integrated and applied in view of using new materials. Mrs. Lagobardi with Professor Formisano then contributed to the discussion by clustering, showing buildings and clustering of monuments with different structural methods and construction processes. And they posed the question of vulnerability assessment for all these different types of structures. Then Professor Psicharis presented a very specific but very important for our region topic of classical monuments. in particular columns composed of drums which are interconnected and there the friction and the contact plays a crucial role. He presented a number of examples and shown that the risk of collapse depends in a not straightforward way on several parameters, for example, the slenderness, the size of the monument, the period of the ground motion, and all these things. At the end, Professor Psycharis presented a novel tendon-based system for stabilizing these structures, and this system had already been applied to a monument in Rhodes. The next presentation came by Professor Mouzakis, who presented two experiments. One experiment of an unreinforced masonry building with different interventions, different strengthening measures, and the corresponding experiments. And a picture, an example from mainly used in Spain and other countries, timber vaults, which represent a specific case of masonry structures in urban areas. The next presentation came from Professor Dritsas, who is an expert and a leading person in cadet regulations. And he presented he mentioned several topics that cadet allows partial satisfaction of its own requirements, depending on the provision of the authorities, introduces the mention of performance levels and the seismic classes of the structures, and allows for a more flexible handling of different requirements between usage and cost and requirements of rehabilitation. Professor Papanikolaou then mentioned a number of threats and ways of using of rehabilitating structures, FRPs, mentioning the fire, mentioning the compatibility issue, and poses some interesting thoughts on further usage or abuse of artificial intelligence in the field of rehabilitation. And of course, the need of keeping a digital replica, digital information about the structures. Professor Pneumatikos then contributed to the discussion by mentioning again the compromise that must be taken between the various stakeholders of the procedure, that means structural, architectural, and conservatory requirements, and mentioned that the decision at the end is certainly a multi-criteria optimization procedure that could be assisted by artificial intelligence. Professor Rocco closed the discussion by mentioning by providing a critical evaluation of the Euro codes, and he also mentioned that a decision must take into account all partners that are involved, and the need to include all these aspects in the next generation of Euro codes and in the research activity within European countries. Thank you.
So, thank to you all. We are quite on time almost. And so I think that we continue now in another room where there are presentations of papers regarding to cultural heritage and earthquake engineering. And thank you, Professor Moropoulou, again for bringing us together.
I thank you for your valuable contribution. I know that some of you came even yesterday because of the strike, like Professor Penelis, but all of you came, my friend Rocco Zarnic came from Slovenia, Antonella from Milano, and all of you came, Yorgos from Crete, Yannis and Nikos from a difficult Athens, and Haris as well. So we very much appreciate your dedication, and not only because you came here, but because of the great work that all of you have performed, and you are still performing in the level of monuments, historic structures, and structures. And we are expecting your message to Athens Declaration. Thank you very much.